Periodic table of elements. Substances made up of only one kind of atom are called elements. These elements, as they have been discovered, have been grouped into a map, called the periodic table of elements, see figure 1.2. This table divides all elements into one of these categories: metals, nonmetals, and gases. In addition to naturally occurring elements, the table lists laboratory synthesized elements. As a whole, these are the types of elements that you will see in the periodic table. Metals. Metals comprise the majority of elements in the table. Some familiar examples include Fe, iron, T, titanium, O, gold, and Na, sodium. Metals do not combine with each other, but do combine with nonmetals. Metals share certain physical properties, including electrical and thermal, heat, conductivity, hardness, a high melting point, and a shiny appearance. Nonmetals. Nonmetals combine with metals, and sometimes with each other. Their physical and chemical properties are roughly the opposite of metals. Nonmetals are poor conductors, are soft, and have lower melting and boiling points. As a result, some nonmetals, such as H, hydrogen, O, oxygen, N, nitrogen, and Cl, chlorine, can exist as gases at normal temperatures. Noble gases, also called inert gases, these comprise any of a group of rare gases that exhibit high stability and extremely low reaction rates. Noble gases include helium, He, neon, Na, and radon, Rn. The periodic table lists elements in order of increasing atomic number, and the rows place the elements so that those with similar properties are in the same column. Within the element block, see figure 1.2, you will see this information. The element symbol is an abbreviation for that element. The element's atomic number designates the number of protons that an atom of that element contains, and is like a fingerprint of that element. The element's atomic mass is the total mass of protons, neutrons, and electrons in a single atom. Isotopes are atoms of the same element, that is, possessing the same number of protons, that have different numbers of neutrons. The mass number of an element is simply the number of protons plus neutrons contained in an atom's nucleus. Note: Figure 1.2 The periodic table of elements. Chemical bonding. In the natural world, elements can be found alone or in combination with other elements. When two or more different kinds of elements combine as a result of a reaction and form a different material, the result is called a compound. There are two basic methods by which elements chemically bond. Ionic bonds. These chemical bonds are formed when electrons are transferred from one atom to another. Atoms that gain or lose an electron, and thus acquire a charge, are called ions. The compounds formed by ionic bonding have a strong crystalline structure with high boiling and melting points. Covalent bonds. These chemical bonds are formed when a pair of electrons is shared between the atoms. 1. H. Hydrogen 1.0. Chemical equations and reactions. As chemical elements come in contact with each other, they may react. A chemical reaction is the process by which atoms of different elements combine. A molecule is a group of atoms bonded together, and it represents the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. Chemical reactions take place in several forms, and chemists describe these reactions by writing equations that represent the elements and proportions involved. Chemical equations are similar to mathematical equations, with the individual elements on the left side of the equation called reactants, and the products on the right side of the arrow representing the resulting compound. Numbers are assigned to show the proper ratio of atoms of each element participating in the reaction. Every molecular compound is represented by a formula that shows its composition. The following are the three main types of reactions. Synthesis reaction, the formation of a new compound from a synthesis, or combination, from two or more different substances. Example, H plus O2. H20. Decomposition reaction, the breakdown of one compound into two or more different substances. Example, CaCO3. Chow plus CO2. Replacement reaction, the exchange or elements or compounds as a result of the reaction. Example, 2 Na plus 2 H2O H2 plus 2 NaOH. If the reaction is caused by another substance, that substance is called a catalyst. In the reaction process, the catalyst increases or decreases the rate of a chemical reaction, but is itself unchanged by the reaction. In each type of reaction, the law of conservation of mass, or matter, states that the quantity of mass, or matter, of the product must be equal to that of the reactants. In other words, matter can be neither created nor destroyed in a chemical reaction. The law of conservation of mass, or matter, states that the quantity of mass, or matter, of the product must be equal to that of the reactants. For example, when mixing 2 hydrogen molecule with 1 oxygen molecule, you get H2O water, as evidence in this equation, H plus O2. H20. Note: solutions, solvents, and concentration. A solution is a homogeneous, uniform throughout, mixture comprised of a solute, a substance that is dissolved into a solvent, the dissolving substance. A common example is saltwater, which can be formed by adding the solute NaCl, sodium chloride, to the solvent water. H20. The solution formed has the same, combined properties throughout as the original elements. Exam alert. A solute is a substance that is dissolved, and a solvent is the substance that does the dissolving. Another characteristic of a solution is that its components can be varied. When more of either solvent or solute is added to the solution, a change occurs in the concentration of the solution. For example, let's say you are mixing up some instant lemonade. You pour water into a pitcher and then add the lemonade powder. What happens? The powder is the solute in this example and is dissolved into the water, which is the solvent. The concentration of your lemonade is determined by the specific quantity of water and powder used. To change the concentration, you must add either more powder, to increase the concentration, or more water, to decrease the concentration. One way of expressing the concentration of a solution is in terms of molar concentration, using the following formula. Molar concentration, M, equals moles of solute liter of solution. A mole is the amount of a substance that contains Avogadro's number, which is equal to 6.02 times 1023 of units. For example, 1 mole of HCl, hydrochloric acid, contains 6.02 times 1023 molecules. Because atoms and molecules are so small and combine in such vast numbers, the mole makes calculations simpler, just as the ton is helpful when working with extremely heavy objects. Amedeo Avogadro, an Italian chemist and physicist, theorized that equal volumes of gases existing at identical temperature and pressure contain an equal number of molecules. This number, which would be called Avogadro's number, was determined through experimentation. Note: there is a limit to the amount of solute that can be dissolved by a solvent into a stable solution at any given temperature. This limit is called the saturation point. Unsaturated solutions contain less than the maximum amount of solute. Supersaturated solutions, on the other hand, contain more than the maximum quantity of solute. These solutions are unstable and, when disturbed, undergo a process called precipitation in which all the excess solute settles out of the solution.